Thank you. So yes, I think James thinks or thought or at some stage considered that I was going to talk about some little protocol called MQTT, and that may come up in the course of the next 15 minutes or so, but hopefully that won't be the whole purpose of this conversation, because actually I have a degree in history, and I'm kind of interested in technology for all kinds of reasons. Love some of the things that have already been said today. I particularly thought that Rick's comment at the beginning of the morning that, you know, there's lots of these protocols and they're not going away. That's kind of an important thing that I want to come back to. I just loved everything Patrick just said, so I'm probably going to say nice things about him further on as well. So when we were first talking about me coming and presenting at a ThingMonk event, James got very insistent that I should be very meta. If anybody ever asks you to be meta, I don't know what the hell that means. So I'm going to try and be meta on James's behalf. And he also mentioned this talk that our friend Matt Biddulph gave a few years ago, actually in 2008. And if you've never looked at these slides on SlideShare, really encourage you to go and have a look. 18 slides, basically summarizing message-oriented middleware and scalability. Really, really nice deck. So really worth your time. Signals then. What are signals? Well, this is a Wikipedia definition. Grateful to Finton for digging this out for me when he was putting my abstract up on the ThingMonk site. Those of you who are scientists, I'm not a scientist, just to classify myself according to Patrick's Venn diagram, I sometimes think of myself as a hacker, but now my company has moved to Shoreditch, I'm definitely a hipster. But those of you who are scientists may recognize some of these descriptions. So we're talking about anything can potentially be a signal that might provide information on the status of something, of a physical system. And importantly, look, I've used the italics font to actually highlight some important details here. Signals convey messages between observers. So I'm going to suggest that signals are all around us and somewhat like the Force, they permeate, you know, our environment. And I think the Internet of Things is all about signals. But the Internet, though, well, the Internet, I think, is made of people. And I think this is something that we very, very often forget, because we kind of get wrapped up as technologists and, hey, look how clever we are. We've got some cool new gadgets. Apart from being a network created sort of by academia and the military and powered by innovations from the porn industry, I would suggest that the Internet is actually all about people, and especially as the social web has taken off. Why is the social web important? And why do people get so agitated and excited about, oh my God, social networks, oh, I don't want to go and use another social tool, oh, I can't get away from Google Plus and everything's suddenly having to go social? Well, the fact is, folks, we're humans. And humans, as a species, are kind of social. We like getting together and coming to events and talking and having the corridor track and sharing experiences and interacting. And just dusting off my historian's toy jacket for a moment, we've kind of spent a long time, centuries, developing different ways of communicating. Now, here are a few which are point-to-point. We invented the ability to write and then to send letters and messages to one another. And then over the course of the last few centuries, the pace of innovation has increased dramatically. We've gone from the telephone, and then we said, well, actually, we don't care about those telephone things anymore. What we care about is data and sending electronic versions of email. Oh, no, and that's too slow. We're going to do instant messaging, and that's much better. And now we can talk to each other really, really quickly. So we've gone from sort of days for point-to-point communication between humans to milliseconds wherever you are on the planet. But point-to-point is not necessarily always the best solution to a problem. Going back to our discussion about signals, the power of broadcast is incredibly important here. And we can get a lot from the ability to broadcast a signal and combine them in different ways. Now, we can go back and think about things like smoke signals, if you want to. If you weren't looking in the right direction, you might miss the smoke signal that was for you. But, this is where those of you who claim to be scientists and happen to know some Morse code get to have a little bit of fun. if I can manage to make this thing stand up on the stand here. Ooh. There we go, nearly. Right, so try not to get distracted by that, but if you can work it out, then tell me at the end. Who knows when Morse code was invented? Who knows when Morse was invented? Anybody? 1836 was when the kind of Morse system started to be invented. Actually, it was invented in two halves. Both the US and the UK came up with telegraph systems around the same time, and they both had a bit of a protocol problem because they started to develop a language in the US, and then that wasn't quite appropriate for whatever reason for the rest of the world. So they had to come together over forming a standard for Morse code. So they had a telegraph system, and they had kind of limited bandwidth. So they wanted to squeeze down the messages they could send. So they came up with this system for maximizing the use of the network called Morse code. And in fact, of course, originally it was sent really on bits of paper tape with little stamps on them. But then over time, they developed, because the system was standardized and they knew what each letter was, they developed the ability to have these conversations either using blinky lights or noises. Now, it's actually stopped being used now. So most of the emergency services, the Navy and so on, were still required to use and know Morse code up until about the turn of the century, up until about 90. I think France stopped using it in 97 and the US stopped using it in 99, which is kind of sad, really. But it's still a universally useful method of communicating, if you're, especially with some of the operators who could tap these things out very, very fast. And of course, there's often, famously, the story about youngsters who can SMS much more quickly and convey messages more quickly than we can send emails and so on. That's where Patrick comes back in, because of course, do we have a new Morse code here? Is chirp, a similar kind of an idea? Well, as he said at the recent IoT accelerator event, the interesting thing about chirp is that it's one-to-many. It has no security, because if you're in audio listening range, you can hear it, and you can pick it up on your receiving device. By the way, I was really hoping that I'd get a Chirpino device to build something cool for this event, but never mind. Looking forward to those anyway. So anyone can see or hear it. So it kind of reminds me of Morse. Now, originally, of course, Morse was intended to be, between two secure individuals, but of course, that's not always the case. So what can we learn here? What about, looking at the lessons we've just learned from point-to-point communication on the internet and broadcasts in a much broader sense? Well, I think one thing is fairly obvious, and that is that connections and sharing are good things. It's nice to have a broad network of people with whom you can share your ideas and receive data and signals. However, things get complicated when things go synchronous, because that's where scaling problems occur. Data and protocols, in particular, make things really hard, because you have to agree a protocol, and you have to agree on data formats. A protocol is essentially like making a handshake, and the data formats are like a language. And if those two things aren't going to match up, then you've got a problem. Let's look at the internet again. So the internet has quite a common protocol. It's called HTTP. It's pretty much everywhere. It's in all our phones, all our devices. People are using HTTP for pretty much everything these days. But it's essentially, it was hypertext transfer protocol. It was built for getting a document from a web server into your web browser so that you could read it. So it was built for request-response situations. And we've bent it and we've massaged it and we've added features and we've done things like, hey, look, the web's a great thing and the web is a fantastic thing. The internet is an amazing, phenomenal technology. We've added WebSockets to the web stack on the principle that we like real time. That's a good idea. But ultimately, this protocol is not efficient and it is not simple. And as somebody else said last week, 2 weeks ago at the Accelerating IoT event, HTTP is not fit for purpose in this space in many cases. It has many methods: put, get, delete, etc., post. Try and figure them all out. It's very verbose. It's text-based. It gets very, very heavyweight if you want to be efficient on the network. But that's fine, because we've all got super fast broadband, right? And we never have any problems with that. and the network never goes down, so we're all okay, obviously. It's point-to-point. If you want to transmit, if I was wanting to send a message to all of you, if I was sending this talk to all of you via HTTP, I'd have to post it somewhere, and then you'd all have to come and get it from somewhere, like SlideShare, which I'll do later. It's quite difficult to scale. We've done lots of things with the technology to enable us to have high-scale, web-scale websites. And of course, we know that Twitter never goes down, so that's fine as well. So let's take a step back again and talk about signals. Well, I'm calling Matt out on this slide as well, because he mentioned the Enterprise Integration Patterns book in his original Made of Messages book. It's a hefty tome. I believe it only comes in hardback, so you know you're getting a really important technical book in that case, and paying twice as much for it. But it's one of those books that has some really fantastic fundamental principles which can easily be applied to this Internet of Things space. And this quote doesn't come from Matt, it's from the book. A message is an atomic unit of data that can be transmitted on a channel. So what we have, if we think of signals as messages, we have a useful piece of data, useful piece of information, hopefully not wrapped up in too much associated metadata, just enough so that we can make sense of it. Broadcasting signals to interested observers is useful, and combining those signals in interesting ways enables us to build really cool systems. So in my opinion, the Internet of Things, or the Internet of Signals, actually is a feedback loop incorporating people who are important on the Internet, things, which we're here talking about, little gadgets that we're attaching to the Internets, all producing signals of different kinds: temperature, pressure, oil price, weather, my last Twitter update, my last blog post, my last Facebook update, whatever we want to be posting, forming this data lake, if you like, this sea of data, cloud of data, and we want to do useful and interesting things with that. Now, as Rick noted this morning, we've got loads of protocols, and they're not going away, and they're all very interesting. And I know at least one person in the room thinks that MQTT has only ever been used by Facebook, which we'll sort out with him in the near future. And in fact, the funny thing about the IoT Accelerator event at campus a few weeks ago was that almost every speaker seemed to stand up and say, you know what, there's this problem with the Internet of Things, there aren't enough standards. But it's OK, because if you all come and use our platform, then we're all sorted. By the way, just out of interest, who here works for an Internet of Things company or company related to the Internet of Things? OK, and then how many of you have an Internet of Things platform? Right, how many of you have an Internet of Things gateway? OK, anyone with a hub? Any hubs around? Excellent, good. Right, so we've got platforms, hubs, and gateways all in the same room. If we all just agreed to use one of those, yours, Yodit, right? If we all agreed to use yours, sorry, I'm picking on you, then everything would be good, right? Because there wouldn't be any interoperability problems. Right, OK, good. Except we'd all have to learn Clojure, right? No, sorry. So I do kind of help to lead / shepherd / generally keep the MQTT community excited. I think it's been a really interesting experience. I haven't been involved with it as long as some of the people in this room, including one of its inventors, but it's been a lot of fun. I think it's a very, very useful and interesting protocol, and I know there was a very brief lightning talk about it here yesterday, so I'm not going to spend 10 minutes talking about all its benefits. What I do want to talk about is the fact that it's extremely simple, it's an extremely lightweight. And I've already spoken to a couple of people here today who've used it for the first time yesterday and said, wow, you know what, I don't know why it's taken me so long because it's really simple and easy to learn. And that's the point. Now, it is a fact that MQTT is going through Oasis, so it's becoming a standard. An announcement that you may not be aware of, although I think it was mentioned yesterday, is that there is a sister protocol called MQTT SN. It used to be called MQTT S. But we couldn't decide whether the S stood for secure or sausages or sensors, so we decided to call it sensor networks instead, MQTT-SN. And that has recently been published under an open license as well. More importantly than the standardization process is that the Eclipse Foundation is hosting an interoperability workshop at EclipseCon in March in California, which if you're involved in the MQTT community, then we'd love to see you at, because if we can't actually get the two ends of the handshake to work, then we're in trouble. I suppose we could have a punch in a hand. No, maybe not. Probably not a good idea. I've been in IT now for, well, it's 20 years since I left school or university. Gosh, it's ridiculous, actually. And I just keep seeing, cycles and loops and wheels being reinvented and turned. We've gone through EAI to SOA, to IoT, to all kinds of other spaces. And standards are useful in all of those spaces. But I think, fundamentally, there continue to be lots of different standards. So integration is actually inevitable here. So I'm kind of using this point of the talk to set up my friend Nick's talk later on about Node-RED. But I'd also like to call out a project at Eclipse, which I'm involved with, Eclipse Ponte. Ponte stands for, is bridge in Italian. And it's all about bridging these different standards in the IoT space. We've got CoAP, we've got AMQP, we've got MQTT, we've got HTTP. These things are going to remain. And there will be lots of different data formats. But if we keep it simple, as far as possible, and keep our data formats simple, and don't suggest that we try and boil the ocean and have one integrated standard, then everything is good, in my opinion. And I'm just going to finish by reminding people that if you haven't gone and read this book, which came out actually in 2006, way before many people in this room probably were thinking about or talking about IoT in its current form, it's really, really good. And it sets up a lot of what we're looking at today. Final thoughts. A couple of amusing tweets I saw recently. Particularly this last one. I'm excited by this statistic. And I'm hoping that at next year's ThingMonk, we'll have more people in the room. Thank you very much.
Thank you.